Okay, for the bell ringer, we've got first on number 48, adding fractions. And you remember, hopefully, from fourth grade, that you need common denominators when you add fractions. So this denominator is a 5, this denominator is a 7. So a common denominator here could be 35. So I'm going to change these into a 35 denominator. And it's a common denominator all the way through, even to the answer. So I write 35 as my common denominator. Now, how did I turn 5 into 35? I had to multiply by 7. So I have to multiply the 3 by 7 to get 21. How did I turn the 7 into a 35? I had to multiply by 5. So I have to multiply the top by 5 to get 10. Now I have common denominator, and I can just add 21 35ths plus 10 35ths is 31 35ths. And that is already simplified. There's nothing that can go into both 31 and 35 that will simplify that. Number 49, subtraction of fractions. Again, we need a common denominator. The lowest number that I can think of that 10 and 3 will both go into nicely is 30. So we'll make 30 our common denominator all the way through even the answer. To get 10 into 30, I multiplied by 3. I have to multiply the top by 3 to get 27. To get 3 to be 30, I multiplied by 10. 2 times 10 is 20. 27 30ths minus 20 30ths equals 7 30ths, which is simplified already. Number 50, now we're subtracting decimals. So it's written in the book, or as the bell ringer, horizontally. I'm going to rewrite this, and I'm going to write it vertically because that's how we do our subtraction. There. 9 take away 7 is 2. 7 minus 0 is 7. The decimal comes straight down into my difference here. And then 8 minus 4 is 4. So my answer is 4 and 72 hundredths. And then adding decimals, same thing. Remember when we write these, and both of these were kind of horrible examples to remind you because they automatically just lined up the decimal. But remember, we have to line up the decimal. I'm going to rewrite this vertically again. And that decimal is going to come straight down into my sum. 1 plus 4 is 5. 8 plus 3 is 11. 9, 1 and 1 is 11 again, and 2. 21 and 15 hundredths. Good job. All right, this is lesson 2.2, found on page 52 in your math book if you want to follow along. Adding rational numbers. Pretty simple because it's just the same rules as you had in fourth grade. You're still just adding fractions, so you need a common denominator. And the 7th grade rules, we're going to have positives and negatives now. So remember, same sign, add and keep, different sign, subtract, because it's like they were integers. We're using the same rules. And that's it. That's the whole lesson. So let's look at their first example. Negative 8 thirds plus 5 sixths. So they need a common denominator. They went with sixths. Notice the negative 8 thirds. They took that negative and they put it up top in the numerator. So now it's negative 16 over 6. They multiplied top and bottom by 2. Now they have a common denominator. Negative 16 plus 5. Different sign, subtract. So they got 11. Keep it negative because the larger of the number parts was negative. Negative 11 sixths. They, in the book, said to go to a mixed number, but keeping it an improper fraction, as long as it is in simplest form, is okay. So I would have left it negative 11 sixths. They also are dealing with decimals here. So different sign, subtract, keep the sign of the larger. So they're going to subtract the number parts and keep it positive because that's the larger of the number parts. And you have to remember with decimals, when adding, you have to line up the decimals. That's pretty much the whole lesson. So here are some to do on your own. Okay, for this first one, negative 7/8 plus 1/4. First thing we need to do, find a common denominator. 8 is a good common denominator here. So we keep this first fraction the same. We have to multiply the top and the bottom by 2 to make this 2/8. Now I can add these. And by add these, since they're different signs, I actually mean subtract their values. 7/8 take away 2/8 is 5/8, and I'm going to keep it negative because the negative amount was bigger. The negative amount had a bigger number value. Number 2, negative 6 1/3 plus 20/3. So now I have a mixed number and an improper fraction. I turn them both into improper fractions, and I have negative 19/3 plus 20/3. Different signs, so I subtract to get 1/3. Kept it positive because the positive had the larger value. For number 3, 2 plus negative 7/2. You turn 2 into a fraction, which would be 2/1. Still plus negative 7/2. Now we go for a common denominator. 2 works out very well. So we multiply the top and bottom by 2 for this fraction to get 4/2. This one already had 2 as a denominator, so we keep it. Different signs, so we subtract. 7 take away 4 is 3, and we keep it negative because the negative had the larger absolute value. Now we're moving into decimals. So when we look at this, negative 12 5/10 plus 15 3/10, different signs. So we're going to subtract. When you subtract these, you put the larger amount on top. Okay, you don't write it with this amount on top all the time. It's whichever has the larger absolute value goes on top. In this case, it's the 15.3 minus 12.5. We find that the difference is 2.8. We put that up there. We keep it positive because the positive had the larger absolute value. For number 5, negative 8 1/15 plus negative 4 3/10. Both negatives, so same sign, add and keep. So we're going to add their number parts. And we get, remember, line up the decimals, 12 45/100. And then it's add and keep, so we do keep the negative sign. So it's negative 12 45/100. Finally, number 6, 65/100 plus negative 2 75/100, different signs. So we subtract. Remember, we put the one with the larger absolute value on top. We subtract the two numbers, and we get 2 10/100, which is the same as 2 1/10, because that 0 is just not needed right there. Put it over here. And we keep it negative because the negative had the larger absolute value. Awesome. Okay, for the next example, they want us to evaluate 2x plus y, and they're letting us know x is 1/4 and y is negative 3/2. So they start with the problem, 2x plus y, and here they substituted in those values, but they really kind of skipped some steps going from here to here. And some of you could probably do that, but I'm going to show the steps. So let's start over. We start with the problem, 2x plus y. In place of x, I put 1/4, and in place of y, I put negative 3/2. Well, now this is 2 times 1/4, which is 2/1 times 1/4. This plus negative 3/2 just kind of follows along because we're not dealing with that part of the problem right now. But we can do this multiplication. Multiplying across the top, we get 2, and multiplying across the bottom, we get 4. So now we have 2/4 plus negative 3/2. This can be simplified to 1/2, which works out very well because then we have a common denominator, which we needed anyway. So now we have 1/2 plus negative 3/2, different signs. So we subtract. 3/2 take away 1/2 is 2/2, and we keep it negative because this had a larger absolute value, negative 2/2, which is the same as negative 1. Here are a couple problems that you can do. Okay, for both of these, a equals 1/2 and b is going to equal negative 5/2. So the first problem, b plus 4a becomes negative 5/2 plus 4 times 1/2. Because remember, 4a means 4 times a, so it's 4 times 1/2. We have to take care of this multiplication first. 4 is really 4/1 times 1/2. We multiply across the top to get 4, and we multiply across the bottom to get 2. Now, I would normally simplify that, but we have common denominators, which we need to do this addition. So negative 5/2 plus 4/2, different sign subtract. When I subtract 5 halves minus 4 halves, I get 1 half. And now I have to give it the negative sign because my negative absolute value was larger. So negative 1 half. For this next problem, a still equals 1 half and b still equals negative 5 halves. So instead of the absolute value of a plus b, I have the absolute value of 1 half plus negative 5 halves, which is the absolute value of negative 4 halves, because 5 halves minus 1 half is 4 halves, different signs, so I subtracted, and now I keep it negative because of the larger absolute value being negative. Negative 4 halves, well, this is really 4 divided by 2, which is 2, so it's negative 2. And obviously the absolute value of negative 2 is positive 2. Now here's some problems for you to work on.